Hello everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 2 in a session October-November 2019 Paper 2-3. So let's start with the first question. Question number 1, solve this absolute value equation. So when we open this absolute, we have a plus minus 3x plus 2 equals to x plus 4. So let me take scaling on both sides. So we have 3x plus 2 whole square equals to x plus 4 whole square. So this is 9x square plus 4 plus 2 times 2 is 4 and 4 times 3 is 12x equals to x square. 4 square is 16 plus 2 times 4 is 8x, right? Shifting all the terms to the left side, we have 9x square minus x square plus 12x minus 8x plus 4 minus 16 equals to 0. So here we have 8x square, okay, and 12 take away 8 is 4 plus 4x, and 4 minus 16 is negative 12, yes. Minus 12 equals to 0. Let me divide by 4. 4 times 2 is 8. 4 times 1 is 4. 4 times 3 is 12. Right. So we have to factorize this. 2 times 3 is 6. And we can say 3 minus 2 is equals to 1. Right. Okay. So 2x square plus 3x minus 2x minus 3 equals to 0. X is common, 2x plus 3, minus 1 is common, 2x plus 3. This is equals to 0. So x minus 1 is a factor and 2x plus 3 is a factor. So x is equals to 1 is the solution, and x is equals to minus 3 by 2, or this is minus 1.5. So these are the two solutions of the equation. Now for question number 2, part 1, we have to show that the left hand side equals to the right hand side. So basically we have to prove the identity. So starting from the left hand side, cosecant is 1 by sine x, cot is cos by sine, cos x over sine x, and whole divides 1 minus cos x, right? Further simplification, let me take sine, denominator is same, just subtract the numerator. 1 minus cos x over sine x whole divides 1 minus cos x over 1, right? So we have 1 minus cos x over sine x into 1 by 1 minus cos x, right? Now we can cancel the like factors. So here we are left with 1 by sine x, and 1 by sine is cosecant x. This is my right hand side, right? Now for the second part, hence solve this equals to 2. So we have to put cosecant x equals to 2, right? So 1 by sine x is equals to 2. From here sine x is 1 by 2. You have to solve this when x is between 0 to 180. So what is x value? X is sine inverse of 1 by 2. Right. Okay, this is in degrees, right? Sine inverse 1 by 2, 30 degrees. So x is 30 degree and sine is positive, and in first and second quadrant. For second we do 180 minus 30, so 150. So x is 30 degree and 150 degree, and both belongs to the domain between 0 to 180 degree. Question number 3, the first 4 terms in the expansion of this are 1, 2, 3, 4, where a, b and c are integers. Show that this equals to 0 and hence find the value of a, b and c. Let me expand this. 1 plus ax power is 5. So 1 power 5 plus 5c1 1 power 4 ax plus 5c2 1 power 3 ax square plus 5c3 1 power 2 ax cube plus 5c4, 1 power is 1ax power 4 plus 5c5, 1 power is 0 and ax power is 5, right? So 1 plus ax power 5, this is equals to 1. Simplify 5c1, 5c1 is 5, this is 5, this is 1 and ax, so we can say 5ax, and 5c2 is 10, so we have 10 a square x square plus 5c3 is 10 a cube x cube, and 5c4 is 5 a power 4 x power 4, and 5c5 is just 1, yes, a5 and x power 5. Okay, now let me do the product and find the first 4 terms, right? Okay, so we can say that 2 plus bx is multiplying with 1 plus ax power 5. So from these terms we have to first multiply by 2 and then multiply by bx. So times by 2 first. So 2 times 5 is 10 ax plus 2 times 10 is 20 a square x square plus 20 a cube x cube, 2 times 5 is 10 a power 4 x power 4 plus 2 a 5 x power 5, right? Now multiply by bx, right? So the first term is multiplying with bx plus 5ab x square plus 10 a square b x 3 plus 10 a cube b x power 4 plus 5 a4 b x power 5 plus a power 5 b x power 6, right? Now this said the first 4 terms in the expansion means constant terms, x square term and the x cube term, right? Now let me rearrange the first 4 terms we have to find, right? Okay, so first we have to pick the constant term. So the constant term is 2 and bx. So 2 plus bx is a constant term, right? And sorry, 2 is the only constant term, right? And then we have to pick the x term. So this is x term and this is x term. So we can say b plus 10a is the x term, right? And the x square terms, these two are the x square terms. So we can say that 20 a square plus 5ab is x square term, and x cube terms are 20 a cube plus 10 a square b, this is x cube term, then x power 4 term, x5 term and x6 term, but we just need the x cube. Okay, and we have given that the first 4 terms in the expansion of this are this, right? So we can say this is equals to 2 plus 332x plus 210 x square plus 3 cx cube, right? Where a b c are integers, right? Okay, let me equate the coefficients, right? Equating coefficients. First, the coefficient of the constant term. This is a constant term 2 and 2. That is same. Just equate the coefficient of x. So the x coefficient over here is b plus 10a. This is equals to 32. The x coefficient, right? Now let me equate x square coefficient. So x square coefficient is 20a square plus 5ab. This is equals to x square, that is 210, right? And the x cube coefficients are, we can, this equals to c. So here we can say that 20 a cube plus 10 a square b, this is equals to c. So we have 3 equations. So from the first equation we can say that the b value is minus 10a plus 32, right? Now let me substitute the b value over here, okay, and simplify. So we can say 20a square plus 5a times the b value is 32 minus 10a. this is equals to 210. So 20a square plus 5 times 32, 160a, and 5 times 10 is minus 50, a square minus 210. So 20 minus 50 is minus 30a square plus 160a minus 210. This is equals to 0 and equals to 0. So let me divide by 10, negative 10. So we have 3a square minus 16a plus 21. This is equals to 0. So we have showed that 3a square minus 16a plus 21 is equals to 0, and hence we have to find the values of a, b, c, and keep in mind that a, b, c are integers. We have to pick the integer values, right? So now we have a quadratic equation in a. We have to factorize it. So 3 times 21 is 63, and 7 times 9 is 63, and minus 7 minus 9 is minus 16. So 3a square minus 9a minus 7a plus 21 equals to 0. Let me take 3a common. So we have a minus 3, negative 7 is common, a minus 3, this is equals to 0, right? So we have the two factors, a minus 3 and 3a minus 7. This is equals to 0. From here, a equals to 3 and a is equals to 7 by 3. So 7 by 3 is not an integer, right? So we are not taking 7 by 3. We can only take x is equals to 3. So when a value is 3, what is my b value? Let me put over here. So b is minus 10 times 3 plus 32, right? So the b value is 2. Yes, 32 minus 30, this is equals to 2. So b equals to 2, right? And a equals to 3. Now let me substitute the a and b value into this equation to get the c, right? Okay. Now 20a is 3 cube plus 10, 3 square, b is 2. This is equals to the c value, right? So now we have 23 cube is 27 plus 10 times 2 is 20, and 3 times 3 squared is 9. This is equals to c. Simplify. 20 times 27, this is 540, and 20 times 9 is 180, is the c value, right? 540 plus 180 is 720. 720 is equals to c, right? So we have c equals to 720, a equals to c 3, and b equals to 2. So these are the three values for a, b, c. Question number 4, part 1, given that y equals to this, write y in the form of vertex form where a, b, c are constant. So standard form of a quadratic equation we have to convert into vertex form, right? So for this, y equals to taking the coefficient of x square common from the first term and the second term, and the third term is same, right? Y equals to 2. We have to take the coefficient of x. This is negative 2 divided by 2 and take its whole square. So this is minus 1 whole square. So this is 1. So add and subtract 1 inside the bracket. So x square minus 2x plus 1 minus 1 minus 7. So y equals to 2, x square minus 2x plus 1 and minus 7 and plus 2 times minus 1. So this 2 times minus 1. So here y equals to 2. This is x minus 1 whole square, and minus 7 minus 2. This is minus 9, right? So this is a, x minus b, and then plus c. Okay, now for the second part, hence find, write down the minimum value of y and the value of x at which it occurred, right? So we can say that the minimum value of y is negative 9 at x is equals to 1. This. Now for part 3, using your answer to part 1, solve the equation giving your answer correct to 2 decimal place, right? We have to solve this equation. So from part A, the equation we have given is 2x square minus 4x minus 7, and this equation is 2p minus 4 square root of p and minus 7. So basically x square is equals to p. So this p is as an x square, right? So x is basically square root of p, right? So this equation has a vertex form. This is equals to 0. So it has a vertex form 2 times x minus 1 whole square minus 9. This is equals to 0. Let me solve in x first. So 2 times x square minus 1 whole x minus 1 whole square equals to 9. So from here x minus 1 square equals to 9 by 2, right? Or here we can say this x is square root of p. So square root of p minus 1 whole square is equals to 9 by 2, right? So taking square root on both sides, right? So we can say square root of p minus 1 is equals to square root of 9 by 2, right? And from here square root of p is equals to square root of 9 divides 2 plus 1. We will get the answer for square root of p. Okay, let me simplify. So 9 by 2 square root 9 divides 2 and then add 1 this answer and then taking square. This is equals to 9.74 up to 2 decimal place. So the p is 9.74 for 2 decimal place. Question number 5, part A. We have to solve this equation for y's between 0 to pi radians. So we can say we have cot square. So cot square y minus pi by 4. This is equals to 1 by 3. And cot is basically 1 by tan, right? So if I can say, and taking a square root on both sides, we can say, or yes, cot y minus pi by 4 is equals to plus minus 1 over square root of 3, and reciprocal of both sides is tangent. Tan of y minus pi by 4 is equals to plus minus square root of 3. Right, now we have two values with a positive square root of 3 and with a negative square root of 3, right? So the first case is tan y minus pi by 4 is square root of 3, and the second case is tan y minus pi by 4 is negative square root of 3, right? Let me find the value of y minus pi by 4. This is tan inverse of square root of 3. The domain is in radians. Convert your calculator is in radians, right? Tan inverse of square root of 3. This is pi by 3, right? So this is equals to pi by 3. Okay, and this here tangent is positive, and tangent is positive in the first and the third quadrant, right? Okay, so let me find the value for the third quadrant. So if it is pi by 3, for third quadrant we do pi plus pi by 3. So plus pi, this is 4 pi by 3. So we have two values, 4 pi by 3, right? So what is the value of y? Y equals to pi by 3 plus pi by 4. 1 by 3 plus 1 by 4, this is 7 pi by 12, right? And the other is 4 by 3 minus plus 1 by 4. 4 by 3 plus 1 by 4, this is 19 by 12 pi, right? Now let me find this for the second one. The tangent is negative, so we can say that y minus pi by 4, this is equals to tangent inverse of square root of 3 is pi by 3, right? Tangent is negative in second and fourth quadrant. Now for second quadrant we do pi minus pi by 3, right? So we can do or we can just do 1 minus 1 by 3. This is 2 pi by 3, and the other is in the fourth quadrant, it is negative. So for the fourth quadrant we have to find the value for 2 pi minus pi by 3. So 2 minus 1 by 3, 5 pi by 3, right? Now let me solve the values of y by doing 2 by 3 plus 1 by 3. 2 by 3 plus 1 by 4, this is 11 pi by 12, right? and we have 5 by 3 and then add 1 by 4. This is 23 pi by 12. Right, now we have 4 values of y. Now we have to check which value satisfy our domain, that is between 0 to pi, right? 0 to 3.14. Okay, 7 by 12, 7 divides 12, this is equals to 0.58. So 0 to 1 pi, so this belongs to the domain. 19 by 12 is more than 1, no. 11 by 12, this is less than 1, yes. 23 by 12, this is more than 1, no. So only value of y that satisfy the domain are 7 pi by 12 and 11 pi by 12. Right. Now for part B, we have to solve this equation for z is between 0 to 360 degrees. Right. So we have 7 cot is cos z over sin z. Tangent is sine by cos. Equals to 7 cosecant is 1 by sine. Right, now cross multiplication we have to do. 7 cos squared z plus sine squared z divides sine z cos z equals to 7 by sine z. Right, now we can cancel sine z and sine z. Right, and we have 7 cos square z plus sine square z. We have to do a cross multiplication. This is 1 and this is 7 cos z. Right, so from here we have 7 cos square z plus sine square z is 1 minus cos square z and minus 7 cos z. This is equals to 0. So this is 6 cos square z minus 7 cos z plus 1 equals to 0. Right, factorize it. So 6 times 1 is 6. So minus 6 minus 1. So 6 cos square z minus 6 cos z minus cos z plus 1 equals to 0. 6 is cos z is common. Cos z minus 1, negative 1 is common. Cos z minus 1, this is equals to 0. Factors are cos z minus 1 and 6 cos z minus 1, this is equals to 0. Right, now for the first factor we have cos z is equals to 1, and from the second factor cos z is equals to 1 by 6. So what is the z value? So from both factors z is positive, right? Cos is positive, right? It is in degrees, domain is in degrees. Okay, cos inverse of 1, this is 0, so z is 0, and cos is positive in first and in third quadrant, so this is 0 and 360. So z equals to 360 degree. Right, and what is cos inverse of 1 by 6? This is equals to z equals to 80.4 degrees, and other is 360 minus this angle 278.79.6 degrees. Right, so these 4 values of z satisfies a domain that are between 0 to 360 degree. We have equality on 0 and 360, so we have to use all the 4 values. Question number 6, do not use a calculator in this question. Number 1, find tan of ACB. A, C and B, the tangent of this angle in the form of r plus s square root of 3, where r and s are integers. Okay, this is a right angle triangle. We have to find this angle theta. So we have the opposite and the adjacent side. So we can say that tangent of ACB, this is opposite over adjacent. Opposite is 3 plus square root of 3 and adjacent side is 3 minus square root of 3. So we have to rationalize this. So 3 plus square root of 3, multiplying and dividing by the conjugate of the denominator. Right, so from here we have 3 plus square root of 3 whole square. 3 square is 9, square root of 3 square is just 3, and plus 2ab, so 2 times 3 is 6 square root of 3. Right, and here in the denominator 3 square is 9 minus square root of 3 square is 3. right? So 9 plus 3, this is equals to 12, plus 6 square root of 3, and divides 6, right? So 6 times 2 is 12, is square root of 3, so 2 square root of 3. So this is in the form of r plus s square root of 3. R is 2 and s is 1. Right, now for the second part, find AC in terms of t square root of u, where t and u are integers and t is not equals to 1. AC. So this is a side AC. It is a right angle triangle, so we have to apply Pythagoras theorem to find AC. The hypotenuse is basically AC. So we can say hypotenuse square equals to AB, that is 3 plus square root of 3 whole square, plus BC square, 3 minus square root of 3 whole square, right? Okay, so AC square, this is equals to, open the square, 3 square is 9, plus 3 plus 6 square root of 3, plus 9 plus 3 minus 6 square root of 3, right? So we can cancel positive 6 square root of 3 with a negative 6 square root of 3. So AC square equals to 9, 10, 11, 12. 12 plus 12 is 24. Right. Now to find AC, we do the square root of 24. And 24 square root is basically 2 times 12 is 24. So 2 times 12 is 2 times 6 is 12. And 6 is 2 times 3 is 6. Right. So these are the factors. So we can take 2 common, square root of 6. So as you can see, we have t square root of u, and t is not equals to 1, t equals to 2. Question number 7. The diagram shows the part of the curve, this curve, and the line x equals to 2. Number 1, find correct to 2 decimal place the coordinates of the stationary point. Stationary point is the point when the gradient of the curve is equals to 0. We can solve for x, and then putting into the curve we will get the y coordinate, right? Now let me find the derivative of this curve. So we have y is equals to x plus 6 into 3x plus 2 power is minus 2. So what is dy by dx? Dy by dx is, we have x derivative is 1, 6 is a constant, power rule is power, the base function power minus 1, and the derivative of base function is just 3. So further simplification, we have 1, and 2 times 3 is 6, and 6 times 6 is 36, negative 36 over 3x plus 2 whole cube, right? Okay, now we have to put this derivative for stationary points, put it equals to 0. Right, now let me solve, put the derivative equals to 0. We can say 36 over 3x plus 2 whole cube, this is equals to 1. So this is negative, so shift on the other side. Okay, so cross multiplication, 36 equals to 3x plus 2 whole cube, right? Now to solve for x, let me take cube root on both sides. This cube and cube root is cancelled. So to get the x value from here, x is equals to, we have a cube root of 36, and then this 2 add, so subtract 2 and divides 3, we have x value. So cube root of 36 minus 2 and divides 3, 4.339, 0.43, you can say. 0.43 is the x coordinate of the stationary point. For the y coordinate, the curve is x is 0.43 plus 6 over 3 times of 0.43 plus 2, its whole square. We will get the y coordinate. So let me just simplify. So the first thing is we can do is 3 times 0.43 plus 2 and the square, and 6 divides answer, add 0.43, so 0.98 is the y coordinate. So the coordinates of the stationary points are 0.43 and 0.98. Now for the second part, find the area of the shaded region showing all your working, right? So as you can see, the shaded region, this is a shaded region. the area under the curve when between x equals to 0, so x is equals to 2, x is 0 here and x is equals to 2. So we integrate this curve between 0 to 2, right? So we can say that the shaded area is integration between 0 to 2 of the curve, that is x plus 6 over 3x plus 2 whole square with respect to dx, right? So x derivative integration is x square by 2, right, plus 6. Let me shift this term to the numerator applying the power rule. So we can say 3x plus 2 power is minus 2 plus 1 over minus 2 plus 1 multiply 1 divides the derivative of 3x plus 2 is 3. Okay, between upper and the lower limit 0 to 2, right? So we have x square by 2. Okay, so 3 times 2 is 6, so and we have minus 1, so minus 2 divides 3x plus 2 and between 0 to 1, 0 to 2, sorry, right? Okay, then we have upper and the lower limit. Let me apply the upper limit. So we have 2 square is 4 by 2, minus 2 divides 3 times 2 is 6 plus 2. This is upper limit, minus the lower limit is 0, minus 2 by 2, right? Well, this is just 0. So this is 2 and minus 2 by 8 and plus 1, right? 2 plus 1 is 3, 3 minus 1 by 4, right? 3 subtract 1 by 4, this is 11 by 4, 2.75 is the shaded area, square units. Question number 8, the roots of the equation are 2, 3 and p, where p is an integer. Number 1, find the value of p. Okay, so this is a cubic polynomial. It has 3 roots. So the first root is x minus 2, the other is x minus 3, and the third is x minus p. So the product of these 3 roots, this is equals to the constant term, this is equals to 4, right? So we can say that the product of 2 minus 2 minus 3 and minus p, this is equals to 24. So minus 2 times minus 3 times p, this is equals to 24. Minus p, sorry, this is 2 times 3 is 6, so minus 6p equals to 24, and 6 times 4 is 24, so p equals to negative 4, right? So the product of the 3 roots, all the 3 roots, is equals to the constant terms. With the help of this information we can easily find the p. Now for the second part, show that a equals to minus 1 and find the value of b, right? We have to show that a is minus 1. Okay, so we have 3 roots, so it means at x is equals to 2, 3 and minus 4, the equation is 0. We can say at x is equals to 2, the first, we can say 2 cube plus a times 2 square plus b times 2 plus 24, this is equals to 0 because it is a root, right? So 8 plus 4a plus 2b plus 24, this is equals to 0. So 4a plus 2b and 24 plus 8 is 32 plus 32, this is equals to 0. Now dividing by 2, we have 2a plus b plus 16, this is equals to 0, the first equation, right? Now x is equals to 3 is the root. At x is equals to 3, we have 3 cube and plus a times 3 square plus b times 3 plus 24, this is equals to 0, right? So 3 cube is 27 plus 9a plus 3b plus 24, this is equals to 0, right? 24 plus 27, 51. So 9a plus 3b plus 51, this is equals to 0. So dividing by 3, 3a plus b, 51 divides 3 is 17, plus 17, this is equals to 0, the second equation, right? Now we have 2 equations. Let me subtract the 2 equations to get rid of b and solve for a, right? So subtract equation 1 and equation 2. 2a plus b equals to negative 16, and 3a plus b equals to negative 17, right? Okay, so for subtraction we have to change the signs, negative, negative and positive. So plus b and minus b is cancel, it's just 0. 2 minus 3 is minus a, and this is equals to 17 minus 16 is 1. So a value is negative 1. So we have showed that a is minus 1. Now we have to solve for b. So what is b? So b is equals to, we can say, minus 16 minus 2 times of a. So b is minus 16 plus 2. So b value equals to negative of 14. Now given that a curve has equation this, find using your value of b, number 3, dy by dx. So the b value is negative of 14, right? So b equals to minus 14. So put b over here and we have to find the derivative. So y is equals to x cube minus x square minus 14x plus 24. Let me differentiate it. Dy by dx is equals to 3x square minus 2x minus 14, right? Now for the fourth part, we have to find the integer value of x for which the gradient of the curve is 2 and the corresponding value of y. Okay, so we have to find the integer value of x for which the gradient of the curve is 2. So this is the gradient of the curve. We have to put it equals to 2 and find the integer value of x and the corresponding value of y. So the gradient of the curve is equals to 2. This is the gradient of the curve. Put it equals to 2 and find the integer value of x. 3x square minus 2x minus 14 minus 2 is minus 16. This is equals to 0, right? Now let me factorize this. 3 times of 16 is 48, and we have to factorize 48 as divide 7, 48 divides 6, 8. 6 times 8 is 48, and we can say 6 minus 8 is minus 2. 3x square plus 6x minus 8x minus 16, this is equals to 0. 3 and x is common, x plus 2, 3 times 2 is 6, minus 8x is common, so x plus 2, this is equals to 0. So the factors are x plus 2 and x 3x. This is minus 8. This is equals to 0. X is equals to negative 2 and x is equals to 8 by 3. This is not the integer value. We are just selecting this x equals to negative 2. Now we have to find the corresponding value of y as well. So put into the curve, we will get the corresponding value of y. So y at x is equals to minus 2 is minus 2 cube minus minus 2 square plus b times x, so minus 14 times minus 2 and plus 24. So what is y? This is minus 8, negative 4 and 2 times 14, positive 28 plus 24, right? So 28 plus 24 minus 8 minus 4, this is 40. Y value is 40 when x is equals to negative 2. Okay, the next is the coordinates of the point P on the curve are given by the values of x and y found in part 4. So P coordinates are minus 2 and 40, right? Number 5, find the equation of tangent to the curve at P. So we have to find the derivative at x is equals to minus 2. So 3 times of minus 2 square minus 2 times of minus 2 and minus 14. So the derivative is 3 times 2 square is 4. This is 12 plus 2 times 2 is 4 minus 14, right? So 12 plus 4 minus 14. This is equals to 2. So the gradient is 2. So now the equation of tangent is y minus y naught equals to m value into x minus x naught, right? This is x naught is minus 2 and the y naught is 40, and the gradient is m, right? So, or if I simplify, we have y equals to 2x plus 4 and plus 40. So y equals to 2x plus 44. This is the equation of tangent at a point P. Question number 9. The diagram shows the points O, A, B, C, D, and X. The position vectors of A, B, and C relative to O are: O to A is A, O to B is 2B, and O to C is 3A, right? O to C, this whole thing OC is, this whole thing is 3A, right? So this is A, so this is 2A, right? The vector DC, D to C, sorry, C to D is B, right? Number 1, given that AX is lambda times AD, find OX in terms of lambda, A, and B. So let me find what is AD, right? So AD, A to X, A to D is A to C and C to D. This is 2A plus B, right? And now we have AX is lambda times of 2A plus B, right? We have to find O to X. So OX follows a path of OA and AX. Let me join O with X, right? O to X follows a path of O to A and A to X, right? OX is OA plus AX. So OX is equals to A is OA is just A, and this is lambda 2A plus B, right? Now for the second part, given that BX equals to mu BC, right? B to X is mu times of BC. Find OX in terms of mu A and B. So let me find BC, right? So B to C follows the path of B to O and O to C. So minus 2B and 3A. So we can say 3A minus 2B. And from here, BX is equals to mu times of 3A minus 2B. Right. Now let me find OX, which involves mu, right? So this path involves mu. OX follows a path of O to B and B to X, that is 2B plus BX. OB plus BX. OB is 2B, BX is mu, 3A minus 2B, right? Now for part 3, hence find the value of lambda and mu, right? So we have to compare OX. So we have OX from the first part is A times of A plus lambda 2A plus B, and OX is 2B plus mu times 3A minus 2B, right? So let me equate both of them, right? And then we can compare the coefficients. So A plus lambda 2A plus B, this is equals to 2B plus mu times 3A minus 2B, right? Okay, now A plus 2A lambda plus B lambda, this is equals to 2B plus 3A mu minus 2B mu, right? Now we have to equate the coefficient, equating coefficients of A and B, right? Now first we have to equate the coefficients of A. So we have A is 1 plus 2 lambda, and on the other side the A is just 3 mu, right? This is your first equation, right? Now for equating coefficients of B, we have B is lambda here, and the other side we have 2 and minus 2 mu. This is my second equation, right? Now let me simplify the two system of equations to get the value of lambda and mu, right? Okay, so arranging the equations, from the first equation we have 2 lambda minus 3 mu is equals to minus 1, and here we have lambda plus 2 mu is equals to 2. Yes. Okay, so if I multiply my second equation with -2, and then we can add in the first equation, right? So we have 2 lambda minus 3 mu is equals to -1. The first stays the same. Multiplying by -2 lambda minus 4 mu minus 4, right? Now let me add both of the equations to get the value of mu, right? So we can cancel this. So 4 and minus 4 and minus 3 is -7 mu and -5. So mu is equals to 5 by 7, right? Now let me solve for lambda. So put into this equation, lambda equals to 2 minus 2 of mu, that is 5 by 7. Lambda equals to 2 -2 times 5 divide 7 and plus 2. This is 4 by 7. So lambda is 4 by 7 and the mu value is 5 by 7, right? Now for part 4, find the ratio AX and XD. Okay, so here you can see what is AX. So A to X is lambda times of AD. This AX is lambda times of AD, and we know that lambda we got is 4 by 7. Yes, so AX is, this A to X is 4 by 7 of AD, right? And what is X to D? So X to D, if it is 4 by 7, then the other is 3 by 7. 3 by 7 of AD, right? Now let me find the ratio of AX and XD, right? So AX ratio XD, AX is 4 by 7 of AD, and this is 3 by 7 of AD, right? Now we can cancel first AD and 7, so we have 4 by 7, 4 by 3, 4 by 3, or we can say that 4:3 is the answer. Question number 10. The function f and g are defined by f of x and g of x. Number 1, solve g f of x equals to 3. So g f of x is ln of 3x plus 2. This is equals to 3. Now g of x is e power 2 times this x, ln of 3x plus 2 and minus 4. This is equals to 3, right? Now we have to simplify and solve for x, right? So e power ln 3x plus 2 whole square equals to 3 plus 4. This is equals to 7, right? Now further simplification, e and ln is just 1, so 3x plus 2 whole square equals to 7, and from here the x opening the square or taking square root on both sides. Yes, this is square root with the plus minus sign, right? So we have 3x plus 2 is equals to plus minus square root of 7, right? And from here the x value is -2 plus minus square root of 7 divides 3, right? Now let's see which value of x. So x is equals to -2 plus square root of 7 divides 3. Let me simplify. -2 plus square root of, sorry, not cube root, square root of 7 divides 3. This is 0.215, 0.215, and x is equals to -2 minus square root of 7 divides 3. Question number 10. The functions f and g are defined by f of x and g of x. Number 1, solve g composition f of x equals to 5. So we can say g f of x, this is equals to g, and f of x is natural log of 3x plus 2. We have to put this equals to 5. And g of x is e power 2, and x is ln of 3x plus 2 minus 4 equals to 5, right? So e power ln 3x plus 2 whole square equals to 5 plus 4, this is equals to 9, right? And E and ln is just 1, so we can say 3x plus 2 whole square equals to 9, right? Now let me do the square root on both sides. So square root and the square root with the plus minus sign. So we can say 3x plus 2 is equals to plus minus 3, right? So from here we have two values of x. 3x plus 2 is equals to 3, and 3x plus 2 equals to negative 3. So 3x is equals to 2 minus 2 plus 3. So 3x is equals to 1 and x is equals to 1 by 3, right? And from here 3x is equals to minus 3 minus 2 and x is equals to minus 5 by 3, right? So which value of x we have to select? So G composition f of x, its domain is, this is the domain for G composition f of x, G f of x, its domain is x is greater than minus 2 by 3. So all the values of x that are more than minus 2 by 3, so 2 by 3 is 0.6, right? So if we can do 5 by 3, this is 1.6, so it is lower. So we this does not belongs to the domain, so this value belongs to the domain. So this is only solution. Now for the second part, find f inverse of x. So we have a function f of x. This is equals to natural log of 3x plus 2, right? Now first we have to do y is equals to f of x, natural log of 3x plus 2. Now x is equals to ln of 3y plus 2, right? And we can say taking exponential, we can converting log natural log to exponential form. So we can say that e power x is equals to 3y plus 2. So e power x plus 2 is equals to 3y, right? Or we can say that from here y or f inverse of x is equals to e power x plus 2 divides 3. This is the sorry, minus 2, shifting 2 here, it's minus 2 not plus. Now for the third part, solve f inverse of x equals to g of x. F inverse of x is e power x minus 2 divides 3. This is equals to g of x, and g of x is e power 2x minus 4, right? Let me do the cross multiplication. So e power x minus 2 equals to 3 e power 2x and minus 12, right? Now let me simplify. We can say 3 e power 2x minus 12 minus e power x plus 2 equals to 0. So 3 e power 2x minus e power x, and from 12 take away 2 is minus 10. This is equals to 0. Now 3 times 10 is 30. Now we have to factorize 30. We can say 5 times 6 is 30, and 5 minus 6 is minus 1. So 3 e power 2x plus 5 e power x minus 6 e power x minus 10 equals to 0. Taking e power x is common, so 3 e power x plus 5 minus 3 minus 2 is common, 3 e power x and plus 5 equals to 0. Okay, the two factors are 3 e power x plus 5 and e power x minus 2 equals to 0, right? Let me solve, put both factors equals to 0. 3 e power x plus 5 equals to 0. E power x is equals to minus 5 by 3, and e power x minus 2 is equals to 0. So e power x is equals to 2, right? So taking ln on both sides, so x is equals to ln of negative 5 by 3. This does not exist. Natural log of negative number does not exist, right? So yeah, here x is equals to ln of 2. This is only solution. Or if we convert this ln of 2, this is 0.63, 0.693. So this is only solution. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.